Hey everybody, this is Larry. This is me doing August 22nd Leetcode Daily Challenge. Oh, the fourth week. Welcome to the fourth week of August. Hit the like button, hit the subscribe button, join me on Discord. Yay, chat about this, chat about the contest, whatever you need to do. Alright, so we're given axis aligned rectangles and you're trying to find the sum of all the rectangles except for modular some number. Alright, let's set up the mod real quick before I think about this because I forget about that a lot. Mod. Okay, so it fit in 64-bit ends anyway. So there are a number of ways to do this. Depends on how many rectangles there are. Given that they're 200, so you can actually do inclusion exclusion principle type thing if n was smaller. But of course, that's going to be 2 to the n, and this is 200, so that's not going to cut it. But given that the axis aligned, we can just do a sweep line algorithm. And what I mean by that is that you can kind of, a sweep line is kind of, you can imagine this visual picture, and a sweep line is a straight line that goes from left to right. I don't know if this video goes back which direction, but it goes from left to right, and as it goes from left to right, you kind of figure out from the previous what the rectangle, and then either you go up or go down or however each way. Okay. I think that's the idea that I would play around with. But one thing to note is that let's see. One thing to note about this is that the corners doesn't have to be, I mean, in this example, this is the case where we always have one on the bottom, but that doesn't have to be the case here. So, so maybe it isn't sweep line. I mean, it's still probably sweep line, but we probably have to be a little bit smaller. Let's see. Well, okay. Okay, I think there is another way. A second way of doing this. I mean, you can do sweep line. So sweep line will work, but you have to do this, what I call point compression. I forget what the name is, but basically compressing the point, which I'll demonstrate in a second. Don't worry. But the second thing to notice is that it's 200. So we can just do 200 squares. So n squared is going to be fast enough. And I think that's what I'm going to do. So the way that I'm thinking about it is, and I'm going to paint up paintbrush real quick, and I'm going to explain what I mean by point compression. I think it's coordinate compression, maybe I'm using the wrong terminology, to be honest. But basically, for example, you can treat every rectangle that we bring in and put it into a grid. So let's actually, let's just say we have this rectangle, we have this rectangle, we have this rectangle, and so forth, right? So of course, you can kind of think about this as a grid. Oops, let me use another color so it's slightly less confusing. So you can think about this as a grid, of course. You match up, and let's just say initially this doesn't have, anything in the betweens, right? But what we're doing here, though, is with path compression, or what I call coordinate compression, is that we're eliminating lines like, let me change the color again. We're eliminating lines like this because this doesn't change the result, right? Because let's say we have coordinates that just goes, we have coordinates that just goes like this, and you can kind of get the area very easily because, let's just say that within each space, not this particular space, but this space, there's a unit of 1, and this space there's a unit of 1, right? So then here you can just basically create a grid, you color these things in, and then you don't have to worry about duplicates, because once you color it in, you just go back and count. So that's basically the idea about it. And and the sum or the total area is just the number of areas filled in. So in this particular case, however, the coordinates could be 10 to the 9th. So that's problem one, because that means that there's going to be way too many squares, right? So you can't fill them in. But the idea about path compression is that, well, I keep calling it path compression, sorry. Coordinate compression is that, okay, so we remove all the non-interesting ones. For example, this line isn't interesting because this doesn't change the answer. So then now, instead, we just kind of care about the coordinates in which the answer may change, and then we'll fill it out that way. So now we have a new grid that's filled with things that are filled with things that are kind of intersect, if you will. And then now, in this new graph, I've colored it over, so maybe that was a bad move, actually, to be honest. But basically, now you can do, these squares, say. And then now you just count the number of squares here, except for that the squares don't have the area of 1. If you keep track of if you keep track carefully what the area of what the areas of these squares are, then you can just sum up all the areas. So that's basically the idea that I'm going to implement here. Hopefully that visualization makes sense. People always ask for graphs, but I don't know if it helps that much sometimes, at least the way that I draw them. So yeah, so now we take a look of all the x's and all the y's, and yeah, just look through them. So now for x, let's see, what is x1, x2, okay. X1, y1, x2, y2 in rectangles. So now let's just say rows reverse sorted set, say. Doesn't really matter. You could do a set and then sort it later, but I'm just going to keep it as a sorted set. So now 2. Just making sure that sorted set is imported, because otherwise I have to find it. I actually don't remember if it is. Oh yeah, okay. So you can just use a set and sort afterwards, put it into list and sort afterwards. This is actually not necessary. It has the same complexity, but I just wanted to make sure. Okay, and then also do the same thing for sorted for columns. So then now we can kind of look at the coordinates that matter to us, right? Yeah. Okay, I guess this is actually a pretty boring result. Wish there was a way to... Oh, there it is. I guess this isn't that interesting either, but might as well put it in. And you can imagine if you have the same thing. Yeah, okay, so this is good. Though I should just put this as an example, as just in case that I need to test it later. But yeah, so now you have all these rows and columns labeled and they're in order. So then now we just want to do a reverse lookup, or enable a reverse lookup. So index x and enumerate rows. Just technically, yeah, okay, fine. Rows lookup, say, or row lookup of R is equal to index. We'll do the same thing for C. And then now we just have to create a grid of what we said, right? So we have to be a little bit careful, but I think it should be okay. Times length of rows plus 1, I think. No, I think this is good, actually. I think it should be -1 to be strict, because I'm just trying to visualize what are the points and where we draw it. I think this should be okay. I also think I got it backwards, so this should be comms for outside. Okay. So then now that we can go through it again. Actually, is this Q square? Because each, so actually maybe I'm wrong on this one, hang on. Because now each fill may maybe I should have done it with, I mean, you need to do this anyway, so okay. Maybe I will do it with sliding windows, sorry. Because I think, in theory, this gets to be as bad as n cube if we're not careful. So I think, yeah, now you do sliding window, sorry, not sliding window, sweep line algorithm, right? So basically now, we're sweeping from left to right. Of all the events. So basically, how are we structuring the events, right? So events, we set it up, and then now for x1, y1, x2, y2 in rectangles. I think maybe we could actually do it concurrently. So let's put this here. So what are the events, right? That means that when we encounter this, so we're going to sweep from left to right, and what that means is that on column X, or on column Y1, which one is Y1? I think as long as I'm consistent, maybe that's okay. So that means that on Y1 we create a span of X1, X2, and then on Y2 we exit a span of X1, Y1, Y2. Okay. So that means that, okay, so that events append the two events, right? One is on X1, we want to add one from Y1 to Y2, and as soon as we get to X2, we minus it. So, okay, I'm going to bring back the point brush for a second. Hang on. I think this part maybe is a little bit... could benefit from some visualization. So basically, with sweep line algorithm, what we're doing is that, okay, let's say we have some rectangle on a line. Why is this so thick? So let's say we have these rectangles, right? So basically what the sweep line algorithm is that you imagine that there is a vertical line, right? That goes from left to right. That goes from left to right. And then as you hit on each event, meaning that now, okay, for example, we set up an event to be the endpoints. I guess this is actually, I think I did it the other way with XY. Maybe I swapped it up. But let's say that this is the case here. Now you're adding this section in, right? And then when you go to the other one, here, for example, you add this section. Of course, there's some overlap. And then now you go to here, you remove this section. So that's basically the idea, and that's basically what we're going to implement. Okay. So yeah, so now this is, and yeah. So now for events.append, oh sorry, what am I doing? For, okay, x coordinate, the delta, y1, y2 in events. Oh, I have to sort first. here now we draw. Okay, let's just say used is equal to let's just say not segments but sections maybe. Is equal to 0 times the length of columns. Yeah. And then now here we can go for y in range from y1 to y2 exclusive. In this case, we do sections of y plus delta. Except for this y, it has to be looked up. So actually, what we want is call lookup of this number, because now we're looking it into the upgraded grid, right? That we're imagining, and then now so we have total is equal to 0 for now, and we have to kind of keep track of let's see. Sorry, let me think about this for a second. We do have to keep track of the previous thing. So previous x, because as time goes by, yeah, okay, is equal to 0, say. It should be okay. So now, so before we update, actually, you can do it in a number of ways, but for y in let me think about this for a second. Okay, so now before we do the update, we know that we moved x minus previous x amount. So this is the delta x, dx maybe. So we know that we moved this much, and actually we want to use no, this is let's just say this is the friend sub 0 sub 0. So this is the first amount, because this should be 0 in the beginning, right? Assuming that we always have at least one rectangle. Okay. So then now the area is equal to dx. So the delta, the width, times everything that's filled in, right? Times filled, maybe? So for y in range of length sub sections. So here we start with filled is equal to 0. Again, this filled is not so this is columns of y minus columns of y minus 1. I think this is roughly right, but I have to think about the starting condition. Yeah, I think this is right. If section sub y is greater than 0, right? Basically, if this is filled, then we calculate what's the height of the thing that is filled, and then we take the area and then do this, and then we go. Okay, I think this is roughly right, maybe. You can actually do this interactive as well as part of this, but I choose not to for laziness reasons. Did we mess up? Oh, I think there is definitely a lot of potential for typos, so we'll see. Hang on. Whoops. Well, that's not great. But I think sections is off by 1, that's why, because this should be. So we are doing the grid. Well, let's double check if it is. Oh, no, that's the other thing. Is that x is equal to, oh sorry, proof x is equal to x. Definitely forgot that, though I don't know if that's enough to fix at least these ones. Okay. I think the idea is right, but my implementation is a little bit sloppy potentially. Let's see. So dx and fill is equal to 0. Okay, so the fill is a little bit wrong. This goes from 0 to 1, maybe? Okay, so dx, it goes from 0 to 1. So it should fill it next time. 0, 0, 0 to 1, so it fills, and then now it should. Let's see. Sorry, having some technical difficulties clearly, but yeah, let's see at least for this one. Also, that's not right. Why do we only care about? There should be way more numbers than this in this thing. Like events should have more items, maybe? Because there should be at least 10 events for this long list. Yeah, there's a lot of weirdness going on. Yeah, okay. So it goes from here. I see. This is y minus 1. This should be plus 1, I think. Okay, there we go. Just off by some indexes. Though things are a little bit weird. I didn't really think about it, to be honest. That's why I said I should have thought about it a little bit more. But and if you have trouble with the indexes, just think about where it represents in the grid, and you should be okay. We could also mod here, but as they said, it'll fit in a 64-bit in, so I don't worry about performance, and it's Python, of course. Do I have more test cases? Let's add more test cases. Alright, just add 2 more just in case. And this is good. I am okay with. Okay, well, that's. I forgot that this dominates it, so. Though it is still right, but I want something more random looking so that I cannot get it by luck. But okay, so this looks good, so let's give it a submit. Okay, cool. Yeah, this is a little bit messier than I had hoped, to be honest. 24 minutes is a little bit long, but it is an interesting problem. I really need to do this a little bit faster, to be frank. So I guess I did a lot of explanation. But yeah, so what is the complexity here? Well, we have a set and we sort, so it's going to be at least R times, or in the rows and columns, it's at most n. In this case, or n times 2, to be honest. So O of n, we sort this anyway. So this is going to be n log n up to here. Here though, it's going to be n squared. So this is going to be an n squared algorithm, because we have O of n items in the events, and this loop, both this loop is O of n because the number of sections could be O of n, and this loop can be O of n. So we have 2 O of n, so it's going to be O of n squared time. And in terms of space, it's just O of n space, right? Because we just have sections, and the number of columns is at most 2 times n. So yeah, so we actually don't use n squared space, so that's cool. Yeah. I think that's all I have for this problem. Let me know what you think. Let me make it a little bit smaller so you could kind of see most of it. Okay, maybe not. Yeah, let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. Hope y'all have a great weekend. Stay good, stay healthy, to good mental health, and I'll see you tomorrow. Bye bye.